Hi, this is Jeff Coronado on behalf of JCSC, and this is a session in Bridging the Gap. So for those of you who are not familiar with sessions of Bridging the Gap, I invite you to take a look at the introduction on our YouTube channel at JCSC LLC, and you'll get a better sense of what we do. However, in the meantime, take a quick look at this information. Gives you an idea of what we're doing here. So with that in mind, let's just jump into our session here. In particular, we're covering the chimney anchorage at the roof, and we're going to cover the purpose of why we anchor an element, a component, such as a chimney, to our roof framing. And we're going to, in particular, look at an example of a residence. Okay, so why do we anchor the chimney of a residence to the roof framing? Let's scroll down. All right, so here's a case in point. Here we have a fairly typical residence in America. Fairly typical residence. Here we have the adjoining chimney to that residential structure. Okay, so we've got a residence, we've got a main structure, the residence, and an attached structure, a chimney. All right, so there's our case in point. Now let me clear the screen here, scroll down. Okay, all objects have a characteristic stiffness. So the roof might take 500 pounds to move 1 inch. The same 500 pounds will only move the chimney a fraction of that inch because the chimney is much stiffer. Okay, so let's take a look at a scale, all right? So let me use the spotlight. So here's a scale like what we see at a grocery store, right? Let's visualize it that way. Let's think of a scale like what we use at the grocery store, but instead of this scale being able to measure 1 pound and 2 pounds and 3 pounds, let's think of it in terms of hundreds of pounds. Okay, so this scale can measure something that's pulling on it with a weight of 100 pounds, 200 pounds, 500 pounds. All right, if we were to attach wires to this roof, all right, we attach, let's say, a wire to this roof. Say we attach a couple of wires to this roof. Stand, I don't know, a few feet away from the roof, or let's say lots of feet away from the roof. And then we attach our scale, okay? We attach our scale, and then we were to pull back, okay? So let's say this is a day that I ate my Wheaties, okay? I ate my Wheaties, so I'm pulling with this scale, and I'm able to pull the roof to a force of 500 pounds until the scale reads 500 pounds. At that point, this middle point of the roof, which is the one that's, I think we can intuitively see, is the one that would move the most, right? So right like at the middle of the roof, if I'm pulling with 500 pounds, the middle of the roof is going to move 1 inch. All right, let's just say it moves 1 inch. So if we were to look at this roof, if we were to look at that roof in what we would call plan view, all right, so that's like a bird's eye view. That's what we mean by plan view. If we were to look at it in plan view and we do that pulling, let me use another color here. Use red. Okay, so again, we're pulling on the roof, right? We attach wires and we pull on the roof. Then, let me use cyan. The roof is going to bow out, right? And so would the back end, right? It'll bow out. So that's what we're saying That bowing out amount is the 1 inch that we're referring to. Okay, so with 500 pounds, we've caused that roof to pull out 1 inch. If we were to do the same thing, to the chimney, where we attach some guy wires to the chimney. All right, so let's say a couple guy wires here, and then we stand back, and again, we pull with our scale. So we put our scale and we pull on the chimney, and let's say we hold that force constant. We're still going to pull at the same 500 pounds on the chimney. I think intuitively, because we can see that the chimney is made out of brick, it's made out of stone, it's made out of mortar. It's not going to budge, right? That's a very stiff structure. That's a very stiff assembly. So when we pull with the same 500 pounds, it's not going to move an inch. It's going to move a fraction of what we were able to get the roof to move. So the same 500-pound force that caused the roof to budge 1 inch is going to cause the chimney to only move, let's say, 1/4 of an inch or 1/2 an inch, right? A fraction of what we were able to get the roof to move. Okay, let me clear the screen and scroll down here. All right, now if we excite the structure laterally in the longitudinal direction, the force will be the same for both the cabin and the chimney, but the displacement will not. Hence, a tear will develop between the two assemblies. Okay, so let's envision a lateral force. That's what we're talking about by exciting the structure laterally. And let's assume that force goes parallel to the long dimension of the residence. That's what we mean by the longitudinal direction. Okay, so this force is acting parallel to the long direction of the residence. So imagine either either wind pushing against the structure, against the residence in this direction, or even imagine an earthquake kind of rocking the house back and forth in this direction. Either way, right? Either one of those would constitute lateral excitation. Now, because the force is going to be the same, right? If it's wind, the wind isn't going to push at let's say 500 pounds on the roof and then 200 pounds on the chimney, or the other way around. The force is the force. It's 500 pounds. Doesn't care what it's pushing. And the same would be true of an earthquake, right? Doesn't care that it's a chimney or a house. It's going to push with the same force whatever it encounters, whatever structure it encounters. So we're pushing with, let's say, hypothetically, 500 pounds against the roof of this residence. And let's say, for purposes of visualizing this, it's going to pull 500 pounds in this direction. Let's see if I can get it right. Let's do it like that, okay? So in the longitudinal direction, well, it's going to displace the roof a certain amount, right? Let's stick to the 1 inch that we've been looking at. But that same 500 pounds acting on the chimney is only going to displace the chimney a fraction of that amount. Let's say 1/2 an inch. Well, we can start doing a little bit of the math there, right? If the roof moves 1 inch and the chimney only moves 1/2 an inch, what's going to happen? Well, yeah, the answer is it's going to cause a tear right here, right? The roof has moved over 1 inch. The chimney has only moved over 1/2 an inch. So it's going to create a separation, a tear between the residential portion of the structure and the chimney. And so that's okay. Well, let's clear the screen and see if we can move down from there. Okay, well, we don't like that, right? We don't like tears in our structures. We don't like different assemblies pulling apart at different in different distances in our structures. So what's the solution? Well, we anchor the two assemblies together. Okay, we anchor the two assemblies together. That's what we mean by. Oh, I'm sorry, I'm jumping the gun here. So what do we mean by anchoring? Well, typically when engineers talk about anchoring, we're talking about something akin to putting Scotch tape across the two assemblies. Okay, so we're going to put literally, we're going to put Scotch tape across the roof and attach it to the chimney. So something like Scotch tape, if we could do that, it wouldn't be able to resist any compression, right? If these two assemblies wanted to kind of, if the roof was moving in this direction and the chimney was moving in this direction, the Scotch tape isn't going to do anything there, right? By the same token, if the chimney wanted to go in that direction and the house wanted to go in this direction, well, this piece of Scotch tape that we have here is just going to tear. It's not going to do anything, right? However, in the situation where the chimney wants to pull apart, the chimney, let's say, is lagging behind, it's not moving as much as the roof, so they want to tear apart, that's where that Scotch tape, if you will, that's where that Scotch tape is really going to be activated, right? That's what we mean by anchoring. So when structural engineers talk about anchoring, we're usually talking about an element, a connection that is going to be able to resist a separation force, a pulling force, usually what we refer to as a tensile force. Let me clear the screen and move on here. Okay, that concludes this session. We wanted to cover what's the purpose of anchoring the chimney to a roof, and that's the purpose. All right, we want to resist that separation. Related bridging the gap sessions. So take a look at any other sessions, any other bridging the gap sessions on our channel that are entitled URMCHIMNEY, because any of those sessions or any upcoming sessions that you see come onto the channel after this will be related to this topic. We will be covering the forces that anchors are subjected to. How do we determine those forces? How do we size the elements of those connections in the anchorage? All of that is covered in other sessions that are entitled, or that will have the name URMCHIMNEY as part of their title. Okay, so just either look for any other sessions currently on the channel or monitor the channel for any upcoming sessions where we will continue to cover this topic. If this was helpful to you, I appreciate if you give us a thumbs up. To subscribe to the JCSE LLC channel so that you can monitor upcoming sessions that we post. Just hover over the JCSE logo that's on the lower right side and click on subscribe. And then I believe there you can set a flag so that you can receive email notifications for upcoming Bridging the Gap sessions. Okay, all right, real good, guys.